Right, we want to find the point on the plane 2x minus y minus 2z equals 6. That is closest to the point 2, 1, and 3. And we proceed as follows. We have been given the plane, right? We have been given the plane with the equation 2x minus y minus 2z equals 6. This plane here has a normal vector, or it's normal. And the normal vector is given as follows. 2 minus 1 minus 2. And now we have this particular scenario here. And this plane can be drawn pictorially like so. Just a two-dimensional formation. And now, if one has the plane, and we have a vector that is perpendicular to the plane, and now which is a normal to the plane, and now we have the point 2, 1, 3. The point 2, 1, 3 is not a point on the plane, but we are interested in finding the point on the plane that is closest to 2, 1, 3. What point on this plane is closest to 2, 1, 3? Okay, now to find the point, we actually first find the equation of a line that passes through this point, and that is perpendicular to the plane. And to find that equation, we use x equals y equals z equals. Right, this line passes through the point 2, 1, 3. And it is in the direction of the normal, where it's parallel to this normal. Right, so, and this gives us, for the x component, twice t minus twice t, like so. Okay. And so if this is the case, and this t is actually a parameter in this case, and so what then do we do here? Okay, what then we do here is because we want to find the point. In other words, you have this line that passes through the point 2 and 3, and that is perpendicular to this plane. So this line intersects the plane at a point, and that is the point that we want. So in other words, now we then say we have twice x minus y minus 2z equals 6. And so x is 2 plus twice t, 1 minus t, z is 3 minus 2t equals 6. 4 plus 4t minus 1 plus t minus 6 plus 4t equals 6. Right, and then we have 4t plus t, which is 5t plus 4t is exactly 9t. Then 4 minus 1 is 3. Minus 6 is minus 3. Added to 6 gives a 9. And dividing through by both left and right by 9 gives us t equals 1. And the point. Right, so the point is given by x, which is 2 plus 2t. Y is 1 minus t. Z is 3 minus 2t, which is 2 into 2 by 1, 1 minus 1, 3 minus 2 into 1, 4, 0, 1. Right. And therefore the point is 4, 0, 1. Okay, now let's pause to reason and think about this point. This point here, is it on the plane? This one. Is it on the plane that we got? The plane 2x minus y minus twice z equals 6. In other words, if we substitute x is as 4, y as 0, and z as a 1, do we get 6? Let us check. 2 into 4 minus 0 for y minus 2z is 1, which is exactly 8 minus 2, which is 6. So indeed, this point is indeed on the plane. Okay. Now, is this point on the line? Well, surely it is on the line. We've already seen that because it was obtained by using the parametric equations of the line. Okay. Next. Now, we had to attempt to answer this question that says we're to find the point on the plane, which we have already got. We've got the point on this plane. But it must be a point that is closest to 2, 1, 3. So in other words, the distance between this plane and 2, 1, 3 must be the smallest possible distance. Okay, I want us to find that distance. Right, so we proceed to find the distance between 2 points in the 3D space. Distance between 2 points. 2 points in R3, in the 3-dimensional Euclidean space. And the points are 2, 1, 3 and 4, 0, 1. What is the distance between these points? So we're going to use the distance formula, which is x2 minus x1 squared. Y2 minus y1 squared. Z2 minus z1 squared. Right, and so now we're going to come here and then say this one here is x1, y1, z1, x2, y2, z2. And what is x2? It is 4 minus 2. And what is y2? It is 0 minus 1. What is z2? It is 1 minus 3. Right, and then now if you have 4 minus 2, it is actually a 2. So that now we have the following. So the distance is exactly 4, because 4 minus 2 is what? Is exactly 2 squared, which is 4 plus 1. And this 1 minus 3 is exactly minus 2. You square it, it's a 4. So it's 1 and 4. 1 plus 4. 9, which is 3 units. So in other words, the distance between these 2 points, 213, the 213 point is not on the plane, and the 401 point is on the plane, and we can see that the distance is actually 3 units. But now there's something of interest for us to find the shortest. The shortest distance between a plane, and a point, What is this shortest distance? The shortest distance is given by AX1, BY1, CZ1 minus D divided by the square root. A squared plus B squared plus C squared. And this is the formula to find the shortest distance between a plane and a point. And what point would this be, for example? Right, so the point, obviously this point is a point that is not on the plane. Right, so otherwise the distance would be 0 between the distance between a plane and a point on the plane. So the point is not on the plane, and the point is x1, y1, z1. Okay. Now let's proceed to answer this question here. So at this point, the plane is given by twice x minus y minus 2z is equal to 6. The point that is not on the plane is the point with coordinates 2, 1, and 3. So that in the end, then, we shall then say the formula is going to be 2x1 minus y1 minus 2z1 minus 6 divided by the square root of 2 squared plus minus 1 squared minus 2 squared. Okay, just squaring the coefficients in the denominator. And here the 6 was transposed to the other side. And then now it remains to substitute the coordinates of this point. So in other words, looking at this pointer, the first one is x1, y1, z1. So that D now is given as follows: 2 into 2 minus 1 minus 2 into 3 minus 6. You divide by the square root here. This is exactly 4. 4. 4 plus 4 is 8 plus 1, 9. Right, so you can write exactly that way. Just reduce the size of the square root here. Okay, so you get exactly that. And then now, if you look at this very carefully, this is exactly 4 minus 1, which is 3. 3 minus 6 is minus 3 minus 6, which is exactly minus 9 over the square root of 9 is 3. Okay, so the distance is what? So the distance now is exactly 9 out of 3, which is 3 units. And this is actually the shortest distance between the plane. So this one is right, 3 units is the shortest. Right, is the shortest. Shortest distance between the plane twice x minus y minus 2z equals 6 and the point. And the point 213. Okay, the shortest distance between the plane 2x minus y minus 2z equals 6 and the point 213. Okay, now this is the point. This is what we have got. The shortest distance is 3 units. Well, I mean, what does all this mean to us? Let us analyze this together very quickly. So we have the plane whose equation is actually that one there. And now we have the point 2 and 3. We have the point 2 and 3 that is a point not on the plane. And so now we are interested in, we actually were interested in finding the shortest distance between this point and a point on the plane. And we have found the point 401. The point 401. And the point 401 is the point on the plane with the equation this. Okay, 2x minus y minus 2z equals 6. We're able to find the distance between the point 213 and 401, and we found that distance to be this one here. The distance between 213 and 401, we calculated it, and we found the distance to be 3 units. Okay, so we found this distance to be exactly 3 units. But also we found the shortest distance between the plane 2x minus y minus 2z equals 6 and the point 213. Also we found that distance to be 3, that shortest distance. And so we've answered this question, but we've answered this question in full that wanted us to find the point on the plane 2x minus y minus 2z equals 6. That is closest to the point. Hence, the point is 401. Why is it closest? Well, because it is the perpendicular distance. This point is a point that is joined to the point 213 by a perpendicular distance. So in other words, hence, the point on the plane twice x minus y minus 2z. Hence the point on the plane, this one, that is closest to the origin. To the origin. To the origin. Hence the point on the plane that is closest to the origin is given by 401. 401. Right, and we are done. And thanks everybody for joining us and for your time, and goodbye to you.